Okay, so I got cut off, so I'm leaving off with number 4. Okay, what you can see here is that I don't have anything that automatically eliminates. I do have the same coefficients here, but not opposite signs. So it would be really easy for me if I multiplied this bottom equation by -1. I'm in essence changing the signs for each one. So now I have a positive 5x, a -4y, and a -1. And that's going to change the signs. I'm going to take the other equation and write the like terms underneath and combine these equations. And what you're going to see is that the 4's now eliminate, the 4y's eliminate. So now I'm down to one variable. 5x plus 2x actually gives me 7x. And 8 minus 1, or -1 plus 8, gives me 7. If I divide both sides by 7, x is going to equal 1. I'm going to take the value of that and plug it into one of the original equations. So, and it doesn't matter which one, I just like to do the positives. 2 times 1 is 2, plus 4y equals 8. And so now when I do that, I'm going to have 2 plus 4y equals 8. Subtract 2 from both sides, and 4y equals 6. I'm going to divide both sides by 4, and you can see that this is not going to go in evenly, but that's okay. 4 goes into 6 one whole time with 2 left over. Your denominator's 4, and that simplifies to 1.5. So your x is 1 and your y is 1.5. So you can see that there, and you can find your answer over here. For the next one, we're going to have to do a little more work. Okay, you are going to end up having to distribute. So when we write that, you're going to have 3x plus y equals 8, and x plus 2y equals 1. So when you have these, you can see that I can't cancel anything out. You really can, you have a choice. You could multiply the top by a -2, and that would be able to cancel out the y's, or you could multiply the bottom by a -3. Because you want opposite coefficients. That's the whole idea. So I'm going to distribute the -3 to each term here. So I have -3x minus 6y equals -3. I'm going to rewrite the other problem, the top one, and now I'm going to combine these. You see that the x values eliminate, -3x plus 3x. I have -6y plus y, that's going to give me a -5y equals, and -3 plus 8 is going to be positive 5. So when I do that, I'm going to divide both sides by a -5. So y actually equals -1. Now I know the value of y, I'm going to plug it back into this equation up here. I have 3x plus a -1. I'm just going to go ahead and write it like that, equals 8. I'm going to add 1 to both sides. So now I have 3x equals 9. So divide both sides by 3, and x equals 3. So your solution is 3, -1, which is what we had there. And you can find it down here. For number 6, you have 6x minus 3y equals -4, and you have -3x plus 5y equals 9. Now, as you can see, I don't have anything that I can just automatically cancel out, but I do have opposite coefficients, so that's kind of nice. So this is where common multiples come into account. I could multiply this bottom by a 2, and if I did that, that would get me 6 here. So I have -6x, I have plus 10y equals 18, and multiplying by 2 is easy enough. Now I'm going to take this other top equation and write it underneath. 6x minus 3y equals -4. What does that do? That eliminates the x value now. Now I have 10y minus 3y is going to give me 7y, and 18 minus 4 is going to give me 14. Divide both sides by 7, and y equals 2. So it doesn't matter whether you solve for x or y. You only have to solve for one of the variables. Once you know the value of one of the variables, plug it back into one of the original equations. So I'm going to plug it into here. 6x minus 3, and instead of y, I'm going to put 2, equals negative 4. So when I do that, I have 6x minus 6 equals negative 4. I'm going to add 6 to both sides. So now I have 6x, cancel the 6's out, equals positive 2. When I do that, I'm going to divide both sides by 6, and you can see that I'm going to have x equals 1/3. And that is your solution, is 1/3 for x, 2 for y, and you can see that that is the F letter. So that was one of your answers. For the last one, this is probably the trickiest one because you're going to have to multiply both of the variable or both of the equations to get opposite coefficients. So I'll show you what that looks like. You have 3x minus 5y equals 25. And you have 2x plus 4y equals 2. So what you're going to have to do is decide, okay, what do I need to multiply? We know that 2 times 3 is 6, so I could do that. But the reason I'm not going to multiply, the top equation by 2 and the bottom equation by 3 is because there aren't opposite coefficients for this. Since these are opposite signs here, it would make more sense for me to multiply the top equation by 4 and the bottom equation by 5. By doing that, that's going to end up having me cancel out the y's and not worrying about the signs. So I'm going to distribute the 4 to each term in this equation. So it's going to give me 12x minus 20y equals 100. And here this is going to give me 10x plus 20y equals 10. Once I do that, oops, I forgot my x there. Once I do that, do you see how the y's cancel out? So now I have 12x plus 10x is going to give me 22x, and 100 plus 10 is going to give me 110. If I divide both sides by 22, x is going to go into 110 5 times. Now I know the value of this. I'm going to plug it back into the original equation, and it doesn't matter which one. I'm going to go ahead and use the positive one. So I'm going to write 2, and instead of x, I'll write 5, plus 4y equals 2. That's 10 plus 4y equals 2. Subtract 10 from both sides. I get 4y equals a negative 8. Divide both sides by 4, and y equals a negative 2. So my solution for that is 5, negative 2. And you can see, so if you solve all this correctly, you end up with perfect.